Live from New York, it's Ask an Engineer.
Hey everybody, and welcome to yet another Wednesday. We wrapped around the week. Time for Wednesday again. Hump day.
Yeah.
But we got an exciting show for you tonight. It's me, Lady Ada, the engineer. We're broadcasting live from our downtown Manhattan factory where we do our manufacturing, our testing, our kitting, our coding, our shipping, our videoing, and more. With me, Mr. Lady Ada on camera control. And we've got like a jam-packed show, about 1+ hours of all the latest videos, news, content, and more in the world of makers, hackers, engineers, etc. Why don't we kick it off? Tell them the code. Tell them what's on tonight's show.
We got a big show tonight. The code is time of flight. I put the little different caps so you can see, like a capital O, capital T, capital F.
Yes.
You don't need to do any of that, but the code is time of flight, 10% off in the Adafruit store, all the way up until probably midnight, because we're going to watch the last What If and then go to bed. But the code will be up until midnight.
Yeah.
Talk about some of our Adafruit live shows, including Show and Tell. JP hosted it. Time travel, look around the world of makers, hackers, artists, and engineers.
Yep.
Help wanted. Nothing on the jobs board tonight, but I have a little job announcement that we have.
Oh, yeah.
Yeah.
We're looking to hire.
Yeah. Main New York City factory footage. 3D printing. INPI. New products. Top secret. We're going to answer your questions. We do that over in Discord throughout the show. adafruit.it/Discord. Save the good ones to the end. All 31,000 people, thank you for being part of the community over there. All that and more on, you guessed it, Ask an Engineer.
Yay.
Okay, so let's go to the code. Remember, time of flight, that's the code. And Lady Ada, when people shop on our site, they can get free stuff.
They do.
What is the free stuff?
$99 or more, you get a free PermaProto half-size PCB. It's great for taking your project off a breadboard and making them permanent, nice and solid. I loved boards like this when I was in school. I used them constantly, and so that's why we give them away. $149 or more, you'll get a free STEMMA QT board. We actually moved a couple around. There were a few that were out of stock, and we're not sure when we're going to get them, so we swapped them out for ones that we do have in stock. Every time you order, you'll get a different one if you have an account. Otherwise, you'll kind of get a random one. So make an account. So it's worth it. That way we can track which ones we've sent you. $199 or more, you get free UPS ground shipping in the continental United States. We do not have the Circuit Playground Express freebie right now because we actually ran out, which is pretty cool. But we have more coming in the next month or so. I don't know if you heard, but there is a shipping and silicon shortage. So there's that.
Yeah, not only that, I guess a little bit of news. We heard from some of our factory partners in China that they can only operate 3 days a week, and then 4 days a week they're closed because they ran out of electricity.
Yeah,
And
there's electricity.
It says electricity shortage.
Rationing.
Yeah, it's unclear.
It's not a shortage; it's rationing.
Yeah,
right. There's electricity. It's just not.
Yeah,
It's not for them.
It's a little unclear all of the details yet, but the price of coal went up. There's also a lot of things going around in the world where we just don't have a lot of transparency into. There was some shipping things around the world that we just ran into. So basically, it's like, get your bingo cards out because there's going to be another crazy per week, per day, per month for a little bit longer. So we'll see how it goes. Anywho, our live shows that we do every single week. This week, JP was kind enough to host Show and Tell.
Thank you, JP.
And I was looking at it while we're getting set up for the show, and it looked like they had like Maker All Stars. So there was Jay, Toddbot. I think it's.
Who else?
Well, we had some of our team.
Of course.
And then there was also, I'm just trying to, I think Darian was there. There was a lot of good projects. So
yeah,
anyways,
there's Ajay, there's Darian, there's Toddbot, there was Liv Clark was
Liz,
there.
Pedro, Scott,
Scott,
Michael. Yeah.
Lots of people.
Yeah, there was a lot of people. So, anywho, check that out. We also do a show on Sundays called Desk of Lady Ada. And we do 2 parts. The first part is what you're working on.
Yeah.
What were you working on this week?
Oh, this week I showed off my final finished AT Tiny 817 UPDI tester. So this tester took way too long. Whenever I have a new chip, it always takes a really long time for me to get the chip up and running because every chip is a little bit different and weird. And it was one of those things where it was like getting like the first 90% was really easy, but then that last 10% actually took like 200 times more time. So the thing that was drive me a little batty with this one was erasing. Whenever I set a fuse, first off, I couldn't set multiple fuses, and I was trying to figure out how I could do that, and I can't. And then every time you set a fuse, you have to do an unlock and erase cycle, which I thought was kind of weird. I kind of understand why. I think it's probably a security thing, but no other chip I know has ever had to do that. Like, yes, if you change the lock bit or byte, you have to, or the protection bytes, yes, you have to erase. But I'd never seen it on like the oscillator byte. So that was a little annoying, but I did get it working, and we published the library. So if you want to make your own standalone UPDI programmer, we now have standalone SWD programming, standalone AVR ISP programming, and now we have UPDI. So we've kind of covered like the three most common. We don't really do PIC kit, although I think the Pixie board that we have is programmed with a PIC, and I think that the creator of the Pixie did publish a library on how to do in-circuit ICSP PIC microcontroller programming.
Okay. We also do the Great Search brought to you by DigiKey and Adafruit, and this is where Lady User uses her powers of finding things on DigiKey and serves them up for you. So what did you find this week?
This was a customer request. It was not a replacement for an out-of-stock part. They were actually asking us, hey, where do you get the foam that you use to ship your feathers that have headers pre-installed? Because they stick out and you have to put them in something protective, and it's best if it's anti-static. And so it turns out there is anti-static foam available on DigiKey, but you have to kind of know where to look because there's only really like one supplier. Like they have plenty in stock. And of course, if you want custom cut ones, you can do as well. But I just buy the big sheets, put the boards in a big array and then just slice them up with a pair of scissors. And I find that that's quite fast. That's what we do here in-house.
Okay. And then if you stick around to the end of the show, we have some top secret. I'm going to show some of our new graphics for Desk of Lady Ada.
Oh, yes.
It's happening.
It's
Okay.
coming.
Every single Tuesday we do JP's product pick. And JP's product pick is when JP broadcasts live from inside of a product page, and you get discounts without having to put any coupon codes or anything. Here is this week's highlight from JP's product pick.
It is the product pick of the week. It is the Pi Ruler. Oh wait, the Pi Ruler. It essentially has a Trinket M0 built right into it. It'll run Arduino or run CircuitPython. And beyond just being a regular Trinket, it actually has 4 of the pins that are normally not broken out on the Trinket running to these 4 capacitive touchpads, as well as 4 bonus LEDs. You can see here on these capacitive touchpads, we have some suggested uses. This is a way to set up a little special keyboard that's really purpose-built for your engineering writing needs. Ohm character, the Omega. We have the mu there for micro thingies, and we have Pi. And then also this DigiKey logo here on the end will actually type in the URL for DigiKey's CircuitPython site and go there. That's the product pick of the week. It is the Pi Ruler.
Okay, and don't forget to tune into JP's show on Thursdays, JP's Workshop. And during JP's Workshop, we have a segment called CircuitPython Parsec. Here is the latest, and tune in for the new one tomorrow.
What I wanted to talk about for the CircuitPython Parsec today is easing the motion of your servo motor. So you're used to servos going choo, 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 really fast from position to position. When you tell them, hey, get to an angle, it just gets there as quick as it can. Well, this is a technique developed by ToddBot for easing or almost adding a low-pass filter to that motion. The way this looks, watch this motion. First, it's going to jump. That's a regular hard stop. Hard stop. Now we're going to ease. And you can see that little easing motion as it gets to its position. It starts quick and then slowly gets there. And if I recall, I'm only playing those hard, fast ones right at the beginning. So from now on out, it should just be, yeah, these nice easing motions. The way this is done, you can see I've got some libraries I'm importing to be able to use the board and PWM IO and Adafruit Servo. Then I am setting 2 positions and how long I want to take to get there. So 0 and 180. I'm going the full extent of the servo. I set up my servo. And then we have this thing here. This is a variable called ease speed. This is the amount of the motion that's going to be spent on the easing and the number of slices to subdivide the motion tail into, in this case, 50 subdivisions. Watch the numbers as they go by. So these are these diminishing numbers that are the smaller and smaller sub-angles that we are traversing at the end there. And this is how it's done. In my main loop, we set the new angle and the number of seconds, so that's from our list. We print that position, and then this is the easing slices. For I in range number of ease slices, the servo goes to an angle plus the new angle minus servo A angle times the ease speed. And then we repeat that until we've gone through 50 of those little sub-slices, which is what gives us that nice smooth motion at the end. Then we sleep a couple seconds and repeat the process on the next angle in the list. And so that is how you can set up a nice easing motion very simply on a servo motor inside of CircuitPython. And that is your CircuitPython Parsec.
Okay, on Fridays we have Deep Dive with Scott. Scott's back this week, so tune in Friday at 2 p.m. Pacific
Raspberry
time.
Pi, low-level Raspberry Pi hacking and making a Raspberry Pi into a very, very, very fast microcontroller.
That's right. All right, time travel. Let's get to some news, videos, retro stuff, you name it. Kind of all fits in time travel because time is what we're all in. There was a video that I wanted to get to this week that was from Phil B that I got to play. That was one of the ones. So I'm 1 week behind. But
Okay, that's fine.
But we're catching up.
But this is part of time travel.
Yeah, that's right.
I showed some neat old calculators last week. Let's focus on this one, the TI Programmer Calculator from 1980. Notice it's a programmer calculator, not a programmable calculator. It's a calculator for programmers. It has some bitwise operations and then conversions between decimal, hexadecimal, and octal numbers. But if you have a whole computer, what does a programmer need with a calculator? Well, 1980 was a different world. Any computer you could afford for yourself would be single tasking. You couldn't just whip up a prompt in the middle of something else to check your math. Or you might be on some hulking beast where the time is so valuable they're not going to let you just poke around on keys until it works. So a lot of code was planned ahead of time, on paper, and perhaps a calculator. Graphics too, I love to see the classic video game sketchbooks. So I'm excited for this modern reversal, that you can now get a calculator with the whole CircuitPython language built in. How cool is that?
Okie dokie, more time travel. So it is Halloween season here. Please check our blog. All the stuff we're doing, yeah, we changed our, the logo on the side. So you know when it's Halloween season here, it's pumpkin spice latte season as well. And then here's just some of the deaths at Adafruit. So a lot of us here are kind of in Halloween mode all year round. And then, we have to pretend not to be in Halloween other months of the year. But this is one of our workstations right now. And I'll take some more photos. We have some fun things in store. And then I think I'm going to play the other Phil video back to back because then I'm all caught up.
Oh, yeah?
Yeah, I'm going to do that.
Right.
Yeah, because I put these all in one spot. And I should have put them one after the other, but anyway.
That's fine.
I wanted to show the Halloween stuff. Okay, so here's one more video from Phil that's continuation of that series.
Showing this old programmer calculator recently, I explained it could convert between decimal, hexadecimal, and octal numbers. It's something that all programmer calculators, even new ones, do. Get into programming and pretty soon you encounter hexadecimal or base 16 notation, a compact way of expressing groups of 4 bits using one of 16 characters. Octal, though, is groups of 3 bits with 8 characters. You may have encountered octal when setting Unix file permissions, but 3 bits doesn't even fit nicely into a byte or a 32-bit word. Well, get this. Bytes weren't always 8 bits. 32-bit systems really started to congeal in the mid-1960s. At the time, this competed with 12-bit and 36-bit architectures. It actually makes sense. Like a clock face, there's more ways to divide this up. The big draw, though, was compatibility with mechanical calculators that banks used. 10 decimal digits needs 35 bits, and round up to an even 36. It all lives on in that octal button.
Okay, next up.
I learned a lot from that video.
Yeah, some AdaBox news, maybe. So there's only like 10 more openings for AdaBox. And heads up, this AdaBox and the next AdaBox, as you know, it is worldwide shipping meltdown, part shortage, no power, squids falling from the sky. There's a bunch of stuff going on. So as soon as we know for sure if any AdaBox is going to be late, it won't be because we didn't do everything. It'll be because of stuff can't
We
ship
were
around.
actually early
Yeah.
on this one.
Yeah, so
But it turns out that didn't really matter.
So we'll let everyone know. And one of the things I'm going to tell folks is like, look, if this is the worst thing that's ever happened to your life, just, cancel your subscription. There's a lot of other people who want it. I think everyone's going to understand what's happened the last couple years. And there hasn't been a definitive, I think, overview of like what's happened. So there's ships that are docked around the world that can't offload the stuff. Once the stuff is offloaded, there's not enough people to drive it around. Between Brexit and Europe and everything that's happened with like regulations and tariffs and you name it, just everything is taking longer. It's slower. When the folks we know in China who said, "Oh yeah, we're only open 3 days a week and 4 days we're closed," and not only that, the stuff we make with you guys. Not only will it take longer, but you're going to get half of it. So just
Yeah.
it is a
It's
a nightmare. It's a
It's
nightmare.
always somehow getting on harder and harder mode in Doom.
Yeah.
I don't know.
So, anyways, we'll let everyone know.
Yeah.
But just please know we did everything early. We did everything in advance. We're gonna we'll figure out something, and even
Yeah.
if it's late, maybe cut us some slack. Okay. Collins Lab notes comes out every Monday, Tuesday, Thursday, Friday. I'm picking two of my favorites. This is the flexible ink display and good old 555 timer.
Okay.
Take it away, Colin.
Yeah.
The basic mechanic of how e-ink displays work is interesting by itself. But flexible e-ink displays take things to another level by making the otherwise rigid layer technology pliable, enough for mounting on a curved surface. Just like a classic e-ink panel, this 2.1-inch flexible display can be programmed via the e-ink Friend Featherwing, either connected directly to the board's 24-pin port or from a distance using an FPC cable and extender, therefore allowing us to mount the flexible display on the side of a container. Or a lamppost on the street. Or maybe the human forehead. You never know. Why is the 555 timer one of the best known ICs of all time? Well, it's been around a long time, and there's a crazy amount of example circuits out there for it. It's also cheap, easy to use, and most of all, versatile. A 555 timer can be used as a timer, performing a single action after a specific period of time. An oscillator, generating a repeating waveform at a specific frequency. A PWM signal generator, outputting a waveform of varying pulse width for controlling servo motors, LEDs, etc. Plus less practical uses, like using two of them together to create a stepped tone generator, aka Atari Punk console. For a modern update to the 555, consider the TLC 551. It's pin compatible with the original, has a wider input voltage, and higher accuracy.
Okay, help wanted. This one's a little different. I might eventually put this job posting on our jobs board because we have a jobs board.
But we have an opening.
Well, we do. We're looking for, this is remote anywhere contract position, and we are going to look for someone who wants to help us manage our blog. So check out blog.adafruit.com and jobs.adafruit.com. Both WordPress. There's a lot of folks that are really good at WordPress, love WordPress. The reason we're doing it because our team does a great job at it, but we just want to do additional things, and we want to find someone cool maybe from the community. I started Hackaday. I have like a billion blog posts online. Make was one of the websites I managed, and then I've been running the Adafruit blog as the like editorial manager or whatever for all these years. And it is one of the neatest websites because you don't have to worry about advertising or ads or monetizing anything. All you have to do is worry about updating to the latest WordPress, making sure it looks good in our template that we have, and that's pretty much it. We moderate all comments. It is a chill thing. We just want a little bit of help with that. And for the jobs board is basically WordPress with this like plugin thing that like kind of works with it. So if anyone's interested, just email me pt@adafruit.com. But just make sure you kind of gotta love WordPress.
Yes.
Kind of the thing. We self-host, by the way.
And we're a very cool team. You got
super fun.
support. You're not going to be alone. We have people who've already done it. We're just so busy doing so much stuff.
Yeah.
We don't have time for
It also means, as you can tell over the last 18 months and in our recent shows, we've been back in the office. We're not wearing masks right now.
We're vaccinated.
Our team is fully vaccinated. So there is a new chapter that's happening here. The Halloween parade in New York is back. There's a lot of good things to look forward to, but we're also kind of like shell-shocked and nervous at all times that what's going to be the next crisis. So anyways, pt@adafruit.com. I'll put this up later, but this is just for like the true fans that are hanging out that might be in this world. And if you know someone, you can do a time-coded URL or just have them email me. Okay. It is Python on hardware time.
Blinka, blinka, blinka.
Blinka, blinka, blinka. Okay, like every week, I try to pick out a few things from the newsletter, and then I have something I focus on. This is kind of neat. Blues Wireless Swan, a powerful Circuit Python compatible board in a Feather form factor. I showed this as like breaking news last week, but one of the things I thought that was kind of neat, Andrew noticed. It says, Adafruit, wondering if you caught Ray Ozzie, the CEO of Blues Wireless, showing off his new Feather board at Edge Impulse Imagine Conference. It can run Circuit Python too.
Yay.
That's pretty neat.
That's right. They did a PR to add support for this chip, which is so awesome. Thank you, folks.
Yeah, so I mentioned this, I think, in a past show, but I also want to mention something. So when MOSFET, our cat, passed away, Ray Ozzie donated money to the cat shelter that Lady Ada got MOSFET from.
Yeah.
And
he got his cat from the same shelter.
And we were exchanging emails, and I know it's silly, but it meant a lot because it was like devastating. And the fact that
I miss MOSFET.
The fact that someone
I mentioned MOSFET today.
I
referred to
think about him every day.
at 10-pound weight. I was like, that's one MOSFET.
Yeah, that's how we measure things. Anyways, and now Ray is the CEO of this electronics company, and they're doing Feather stuff, and it has CircuitPython. So, anyways, maybe check it out if you like cats. Anyways, the Raspberry Pi released a new datasheet, the RP2040 datasheet. It is gigantic, so check it out. It has everything. Next week, Ada Lovelace Day. I'm going to show some of this video. We did a virtual factory tour, so stick around for the show tonight, and you'll see the rest of it. I thought this was neat. Python 3.10, they had a release party, and they're starting to do these cool...
3.10.
Sorry, 3.10. Oops. They're starting to do these cool graphics where it has like some of the stuff that has something to do with
I think this is cool. I think we should
Yeah.
have like tattoos, like temporary tattoos for release.
Yeah, like we have a
Candidates.
poster, and I'll talk about that for each thing that we do. The Halloween Hackfest with DigiKey and Hackaday and Adafruit, that's still going on, and it's Open Hardware Month. Talk about that again. Make sent out a big old thing, getting started with Python on hardware, and this is kind of neat. Teaching Python podcast made this CircuitPython error bingo card. So if you are learning a programming language and you get an error, normally it's like, oh no, I am the worst. I can't believe this is happening to me. The folks over at Teaching Python podcast decided to make it into a fun game. And I think that's the way to do it. If we can normalize making mistakes, it'd be way better than the alternative. And then, catch out the rest of the odds and ends. I think there was one more thing I wanted to show. Oh, yeah. The Pico System, it's a pocket-sized handheld console built around Raspberry Pi RP2040. It uses things like C++ and MicroPython, and, of course, CircuitPython. And so that is the newsletter news. And then speaking of launch graphics, so the Python 3.10 graphic thing is there.
We have friendly snakes.
We have the great merge poster. So CircuitPython 7, it's out now, and we wanted to like show that MicroPython and CircuitPython are on a collision course together, and now they're like one snake. One snake absorbed the other snake, so it's one snake. So a lot of the MicroPython stuff is now in CircuitPython. Next up, I play this video from Jepler. We have a cool camera thing.
Hi, Jeff here. I've been working on supporting another camera module in Adafruit CircuitPython. This time it's the OV5640. I had to put it on a long extension cable to get the shot I wanted of the LCD, and that's what's leading to the glitches that you're seeing here in the video. What's working is RGB, YUV, and grayscale capture, and of course display to LCD. You can also control the saturation level and turn on special effects such as sepia, negative, and test pattern. Next up is implementing JPEG image capture at a startling 5 megapixels. The library will be added to the CircuitPython bundle when it's ready. See you around.
Okay. And then there was a question, is there a name for this snake Hydra? No, in fact, I tried to find out if there was
There's
a name.
not a snake hydra. There's 2 snakes.
Yeah, but they're kind of like,
Oh, the MicroPython snake?
yeah, well,
I don't
so,
think it's called the MicroPython snake.
yeah, so I asked Damien, and he's like, there's no name for it. And we redrew the snake for him because I don't think he had the artwork, so he made one for him. I don't
There's
know.
2
if they-
snakes.
Yeah.
It's Blinka and the MicroPython snake.
Yeah, but they're kind of like maybe.
But no, they're not.
Yeah.
If you look carefully, they
No,
curl
I know,
around.
but it looks like it could be a 2-headed snake, and that happens in nature quite a bit. At least more than maybe other types of animals.
Okay.
Anyways, so back to the camera stuff. So here's more photos from the camera.
JPEG photos, testing out some different JPEG modes.
Yeah, and I think
That's
this
not bad. This is a very low cost, couple dollar camera module, and it works quite well.
Yeah, I think it'll be neat when you're able to build your own DIY camera.
Yeah.
Anyways, and that is Python hardware news this week. Okie dokie. We are an open source hardware company. It is open source hardware month. Go check out ohm.oshwa.org. And the latest thing that I saw that was kind of cool. So Michael Weinberg was on the show and tell last week talking
Yes.
about Open Hardware Month, and he's like, "There's a big
Yes.
surprise coming soon," and this is it. The guidelines for sharing FPGA designs are now published.
Yay!
Lady, for the folks who don't know what an FPGA is, what are they?
An FPGA is a kind of chip that you can turn into any other kind of digital chip, which is really cool. Because usually a microcontroller, you can program it with code, but you can't change the underlying peripherals or the underlying core. Like if it's a RP2040, it's an RP2040. It's an 8051, it's an 8051. It's a Zilog Z80, it's a Zilog Z80. But with an FPGA, you can program it with any chip, but customize the chip itself. And it's instantly fast as well. Everything kind of happens at once, which is very powerful. A lot of people use FPGAs for very timing sensitive stuff, video stuff, where you have to push a lot of data around very quickly, or for prototyping new silicon. So when you're designing a new chip, you use an FPGA to design it.
Okay. All right. In addition to us being an open source hardware company, we have 2,553 guides to prove it.
Yes.
This week on the big board, Lady Ada, what do we got?
Okay. All right. Starting with we've got. I like it's kind of like wide.
Yeah.
It's like chunky. We got from Dylan a Whippersnapper project. Whippersnapper is our extension to Adafruit IO. It comes free with Adafruit IO, where you can make projects without any code at all. So it's a no-code interface for making IoT and sensor projects. And then, so just showing how to make a door alarm. So one example that emails you when the door opens. We also have a guide from JP on using those inductive coil LEDs to make models, showing a couple different models. One is like a Star Wars model. One is, I think, a figurine model. And we also did a Lego model. So different techniques in how to build a stand and how to really use these inductive LEDs in the prettiest way. Also got a guide from Kattni on the A&O directional navigation and scroll wheel rotary. So it's basically iPod Classic wheel. It's 4 buttons and then like a little rotary wheel that clicks, and it's very tactily and enjoyable. We have that sensor and a breakout for it, and Kattni wrote code and a guide for Arduino and CircuitPython. And then from Liz Clark, Noah, and Pedro, we've got this cool mini LED matrix audio visualizer. You can just plug one of our 13x9 RGB LED matrices into a Feathersense and run some CircuitPython code that'll take fast Fourier transform and show you some cool bubbly LEDs.
Okay, we got 2 more.
Also, Dan Halbert, I think either updated or wrote this guide on custom HID devices. So if you want a custom descriptor for an HID device, for example, you want to mimic a Microsoft rotary surface dial, you can do that now. It's something that is, was possible in Arduino, and if you were willing to code some C code, you could do it in CircuitPython. But now you can do it purely in Python, which is really cool and powerful. You can make custom HID devices. So if we don't natively support the device you want, we can still interface with it. And Dylan wrote another Getting Started with Whippersnapper guide. This one is just button press inputs. So it's a very beginner guide on like your first Whippersnapper project.
Okay. Made New York City factory footage. This week we're going to do something a little different.
Yeah.
So on Friday of last week, it was Made New York City.
Like how we're in it, but we're not in it. Like,
Yeah, it was
hi.
Made New York City week,
Yeah.
and Adafruit is, I think, one of the only electronics manufacturers in Manhattan.
I think so.
I think so. And then it was also Manufacturing Day.
Yeah.
So all on the same day, so we said, okay, fine, we'll do a factory tour. So this is a slight speed up. This isn't exactly, because I wanted to be around a little bit over a minute. So this is where we ship stuff. One of my desks, I have a desk on each floor here at Adafruit, but this is where we do a lot of the shipping and storing of things. All of this is velocity storage, so the things that we ship the most of are closest to the shipping stations, and you could see a whole bunch of Adafruit products around here. Things are a little different since we've had COVID happening in our lives, so obviously you see people wearing masks. We changed some of the layout and some different things, and we're also continually trying to maximize our space. But I wanted to do a little video, so I asked Dano, who works here in manufacturing, to run down and make a quick video, because it's really hard to do a multi-floor live broadcast, and so this is the other part of the tour that we did. And then this is the other side of one of our floors. This is where we have a whole bunch of storage.
Yay, boxes of stuff.
Stuff and stuff and stuff
All
and stuff
labeled
and
and
stuff.
counted and accounted for and tracked, and
Yeah.
this is where all the backlog.
Back when we were an apartment company, our storage was in the living room and shipping was also in the
we had a
living room.
closet.
Yeah, we had a
Oh,
closet
yeah.
full of boxes.
But now, we have a lot more
Yeah,
stuff.
so it definitely has that Costco feel a little bit, and you can see more of that area. Then we also did a little bit of filming of the other floor, and this is where we're at right now. So this is where we do a lot of manufacturing.
You can see the pick and place machines here. So the 2 pick and place Samsung machines,
Yeah.
the inspection space station, the oven, the testers for the upcoming products, the nitrogen generators. Yeah, it spins around. The rework and testing benches. A lot of these we've actually spread out a lot of people. There's me,
You're
hi,
there.
hello. And then there's Phil over
Hi.
there, hi. And then we've got the hack sign, hack. And let's see what else we got. Oh, the real storage and component storage. Old oven that we keep around in case we ever need it.
And then a
More
TARDIS.
reels,
I
a
think.
TARDIS. Well, we kind of saw that a
Yeah.
little bit.
Okay, so that's the
samples,
tour.
and then that's where we film. So this
That's
is
where we
this
film
is,
right here.
This is where you see us. Hello.
Yeah, that's
how
where we're sitting right
That's
now.
where we're sitting now.
Huh, that's cool.
Thanks,
I
Dan.
didn't realize it ended like that.
Ta-da.
Okay, and then I'm going to show the rest of the regular old factory footage that we do each week. So here we go. And it wouldn't be Adafruit factory footage unless you could see the Disney, Marvel, whatever.
Complex.
I think I figured it out. We are the Watcher.
I guess we're watching
What
it.
if this building is never completed?
I
won't interfere,
don't know, man.
except for once.
They're going pretty fast.
Yeah. Anyways, okay, let's do some 3D printing. Okay, we're going to play these back to back. We have a little visualizer, and then we have this really neat speed up video of this like little lizard creature. looking
Hand
thing.
lizard puppet. Yeah, it's
cool.
cute.
Hey, what's up folks? In this project, we're making an LED audio visualizer. We designed and 3D printed a case for this lovely little LED matrix and an Adafruit feather. This is a 13x9 LED matrix that features the IS31FL3741 LED driver. It's packed with 117 RGB LEDs that are 2x2mm in size. Stemma QT connectors make it easy to plug and play over I2C, so it's easy to connect to a microcontroller like the Feather RP2040. The Adafruit Feathersense NRF52840 features a PDM MEMS microphone for audio projects. The LED driver features libraries for both CircuitPython and Arduino, so it's easy to quickly get up and running. In the demo code, RGB colors are set up in an array to generate a heat map of the incoming audio data. This demo code was ported by Liz Clark from the Microlab Waterfall Spectrum Analyzer. This particular demo was written by Philip Burgess and features a bounce effect when the audio is peaking. The Microlab library allows you to crunch numbers fast in CircuitPython with NumPy-like commands to quickly process data. Be sure to check out the Learn Guide by Jeff Epler for a full breakdown on using this library in your projects. The LED matrix and Feathersense NRF52840 are secured to a PCB bracket. It's secured to the 3D printed enclosure with M3 hardware screws. The case and back cover snap fit together for an easy assembly. On the side of the case is a port opening for connecting the feather over USB. We designed a built-in button pusher so you can use the reset button without having to take it apart. We had a lot of fun putting this one together and hope this inspires you to pick up the LED matrix and the Adafruit Feathersense. Make sure to subscribe for more 3D printed and CircuitPython projects from Adafruit.
don't forget, every single Wednesday, 3D Hangouts with No Page, where you can learn how to make this. I like the build up and build down of the little croc, because it looks like one of those nature shows where
Yeah.
like a fox decomposes.
Yeah.
It's like, roar. Anyways. Okay, lady, it is time to do an NPI.
That's right.
on NPI.
Okay, Eye on NPI is brought to you by DigiKey and Adafruit. Every week we look at the latest, newest stuff from DigiKey and more. Lady Ada, what is this week's Eye on NPI?
This week's INPI is a Raltron crystal oscillator kit that I saw pop up on digikey.com/new. They got a cool logo. Raltron, apparently they're like I think in Miami, Florida. So it's cool. They have really great weather there.
It's like
and
Tron's uncle.
Raltron.
Hey,
Yeah, and they've
Raltron.
also got great crystals, so why not?
It's a Rami technology company.
I guess they're that's
Yeah.
something, but they're a small business and they do manufacturing and they're here in the U.S. So let's check out this week's new product.
Okay.
Okay, so the new product is this crystal resonator design kit. So chances are you've used.
This is like the best trapper keeper ever.
It basically is a trapper keeper. So crystals. If you've never used crystals in your electronics, they're not necessarily like the bedazzly type crystals. Instead, they're the kind of crystals that come in a metal tin. Usually you have to have 2 capacitors with them to stabilize the oscillator. And inside the crystal actually is a little piece of piezo-resistant material. It's a crystal. It's not like a amethyst type crystal or like a quartz crystal, but it is a crystalline material. And when voltage is applied across it, it vibrates and it will oscillate back at a certain frequency. And so by setting up in a feedback loop and you kick it once, you can get quite precise oscillations out of it. So what these are used for is creating a timing signal for microcontrollers and other chips that need to have a precise measurement of time, because you can make an RC oscillator, but RC oscillators they're not very precise. They have plus or minus maybe 5 or 10%. Maybe you can sometimes tune them to get 1%, but a crystal oscillator is going to work much, much better. You're going to get maybe 20 to 50 ppm. That's pulses per million or parts per million error rate, which is pretty good for a timing oscillator. And so oftentimes your microcontroller will use a crystal also as a source for a multiplier, like a PLL, to multiply that frequency, but we'll get to that. The most common crystal kind of used like in any electronics is the 32.768 kilohertz crystal. The reason, that's quite an odd number, like why 32.768 kilohertz? Well, because that is a 2 to the 15 number, and so if you have a binary counter in your microcontroller, and binary counters are very inexpensive, as it counts from 0 up to 32767. When it gets to 768, it will flip over, and that overflow will let you know that 1 second has passed. So it's a very easy way to count 1 second. So it's used for timing. So in this case, this board that is shown here has a real-time clock. So it's something that keeps time. It runs for years on a coin cell battery. And it can do that because 32 kilohertz is quite slow. It's a common crystal value, but it's slow enough that you're not running very fast electronics. It sips power like microamps or less. So there's a lot of different values. So this kit, and I'll open up the kit, of course, and show you the pages inside. It has the most 32 kilohertz crystals. Like it has all sorts of different sizes and packages. And also the load capacitors. Now, yes, oftentimes you have to pick the load capacitors that go with your crystal. Like if you look here on this Arduino board on the left, you see there's kind of the metal tin, and then above it there's 2 little yellow dots. Those are the load capacitors. Sometimes you pick them, but actually sometimes I've noticed certain chips or devices, they actually have the load capacitor like a tunable number inside the micro, or like you kind of have to pick a certain loading value, and so that's why they have multiple. Even though I tend to use 12.5 picofarad for 32 kilohertz, and maybe I use 18 picofarad for 12 or whatever. They do give you a full range with multiple sizes and also load capacitances. So I showed you the 32. I call them 32 kilohertz, but they're 32.768. They also have a lot of microcontroller, common microcontroller values. Like if you have a USB microcontroller, you're going to have 6, 12, or 24 megahertz because USB is a 12 megahertz protocol, and so you're going to have something that's like a multiple or a divisor of 12. A lot of microcontrollers also like to run at like 8 or 16 or 20 or 40 megahertz. Those are pretty common values. The microcontroller sometimes runs at that value, but again, it's pretty common for inside the microcontroller, there's a phase lock loop, and so there's a non-precise higher speed oscillator that they then tune against the precise lower speed oscillator. And that way you can, a lot of microcontrollers these days, you may have noticed, you can actually change the clock speed, sometimes even on the fly. So, original AVR microcontrollers, I think you could maybe clock divide only, but in the SAMD21, you can clock up and you can even overclock if you'd like. Or the SAMD51, you overclocked it to 200 megahertz, even though it only has, I think, a 16 megahertz crystal on it. But it's important, especially if you're doing radio frequency stuff, you want to have really good, precise crystals. Next up, there are a couple of weird values in here too, like 27.12 megahertz. You're probably like, okay, that's an odd value, and it's not even like a multiple of 2. What is up with that? This is a RFID board. So this is a PN532, and it's an RFID transceiver board. And RFID for like NTAG and MyFair chips is 13.56 megahertz. That's the frequency, and so multiply that by 2. You get 27.12. So that's another thing. If you have certain RF work you're doing, you'll need to really get that crystal to be the exact multiple. Also, if you're doing, video stuff, old NTSC video, you had to have the color burst crystal, and it was like 3.96 megahertz. The crystal actually does matter. You don't round up or down. You want to get the exact value. And again, you want to have the loading capacitors match because that'll get your value as close as possible to the stated. So inside the binder are all these pages, and I think that these are I'll show them also on the overhead, but I think they're pages that are used for like baseball cards or something.
Yeah, this was clever.
So each inside there's a 5-piece cut tape of each crystal, and they're in the little clear pockets, and then behind it is a printed out piece of paper that is behind the clear part, and it has the part number, the frequency, the stability, the load capacitance, the ESR, operating mode, operating temperature, and size. And then there's also a short URL that you can go to get the data sheet, and also a QR code. One nice thing about the short URL, they got their own URL shortener. Big ups for that, because it would have been really easy to use the Google one or Bitly. They actually got their own, which is very smart. Don't rely on other people for your URL shortening.
What are the chances of a giant global network going down and no one being able to communicate or anything? Probably not. Okay.
Unlikely.
Well, it's available on DigiKey.
That's right. So you can pick this up. DigiKey also has capacitor kits and resistor kits. I always recommend having a resistor kit and capacitor kit. I use them all the time. We sell some in the shop, but DigiKey also has them. Nothing beats having a resistor and capacitor kit. You never know, you need some weird value.
Short URL here.
And a crystal kit, also really useful, because sometimes you don't realize you're laying out your board, you get all the parts, you don't realize, oh shoot, the crystal I need is the wrong size, or I need a slightly different frequency. I misread it, I thought it was 20, it's 24. The crystals are used in everything, right? So it's not a bad idea, just like you have your kit of regulators, your kit of resistors, your kit of connectors. Get a crystal kit as
want to
well.
show this book?
Yes.
All right, I'll show this book and then we'll...
Okay, so design kit for crystal resonators, thank you. So there's little instructions on how to use it, and then basically this is how it works. So you see that there's these clear pages, and they're used for baseball cards or whatever, and then underneath it there is for each one a description. So these are super tiny 1.2 by 1 millimeter 32 kilohertz crystals. And then moving up, there is 3.2 by 1.5. And then they've got 32 megahertz. They've got 25 megahertz, 27.1, 2, 27, without the 1, 2, 32, 37.4, 38.4, 40, 48, 16, 20, 24, 25. So they have a couple different frequencies in different sizes. But they kind of cover them all. These are all the most common frequencies I've seen. And of course, once you've used these in your production, and you're happy with the package and the size and the stability, you can, of course, use that part number, type in DigiKey, and then purchase it by the reel, to your heart's content. So you go, you got 66 different values, and then 5 pieces of each value, so multiply that out.
Okay, and that is this week's Eye on MPI.
TikTok.
Eye on MPI.
Okay, let's show the code, time of flight, and then let's jump right to new products, Lady Ada.
Okay.
New.
New.
Here we go. Okay.
Okay.
First up, this is a revision.
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 It's actually such a revision that I don't even actually call it a revision because you
It's
don't
not
even
a
know.
revision.
You don't even know what changed. So if you look carefully, you'll see the DFN version of this chip, the LC 7092, whatever, is no longer available. We can only get the BGA version, and so I respun the board for a BGA chip. It's a smaller chip. It's exactly the same component, same pinout, same functionality. It's just
Now
BGA.
it's just available.
It's just available, and this is part of the silicon shortage.
Next up.
Next up, we've got these little dust covers. We got them a while ago for like USB and USB-C and USB-A and HDMI and micro USB, and people are like, well, I want mini HDMI. So this is the mini HDMI plug. Fits perfectly into your Pi Zero, which is kind of like the most handy thing.
Next up.
And if you want micro HDMI little dust cover plugs, we've got those too. These are rarer, so they're not as cheap. But you get a pack of 10, so you plug to your heart's content, and if you lose them, no worries, you've got more. Actually wish I could, I should get like the 3.5 millimeter plug because like, you know, I actually get little, like it's dusty in my room, and like when I plug in my headphones, sometimes it's like there's a little dust inside. So I'm gonna pick up some of those for home.
Next up.
We've also got an update. We finally got in the 6-pin version of this Pico blade, I think it's 1.25 millimeter pitch Pico blade connector, you know, A to A type. You know, people are making their own, you know, boards. They want a very nice, durable, extremely compact connector. This will do the job quite nicely with 6 pins.
Next up.
We're also carrying, you know, we stocked a couple different, I think we stocked the 24-pin version of these extendos, and now we have them in 20, 30, 40, sorry, 20, 30,
Yeah.
whatever. I'll actually, let me look.
We've got a variety of choices
they're
for
right.
you.
Hold on.
And you can see the photos of them as Lady Ada gets these out.
Yes.
So we
I
got
apologize.
this time.
Here's
We got this time.
Okay.
Alright, you want to show this off?
Yes. So I think these are the 20, 30, and 60. Because, focus a lot. Because we already had the 40 and the 24. So basically, if you have something with a flex connector and you want to extend it, what you would do is you get an FPC cable, which you can cut an existing FPC cable down, or you can get another one. And what's just nice about this is that it has 2 little ear nubs on each side. And then when you plug them in like this, they're now connected through. And so you can use this to extend your flex circuits. And they do so very compactly. I do like how cute and adorable these are. So you have flex cables. If you don't have the exact flex cable you need, check DigiKey. They stock flex cables of every sort and kind. We use them for basically if you have a 40-pin TFT cable, 40-pin TFT, you want to extend it farther away, you use one of these plus a plain flex cable, like so, and make a little extendo out of them. So it's very inexpensive and compact, and I think I kind of like these more than the PCB versions because they don't get in the way, they don't snag on anything.
All right, next up.
Okay, next up from Tech, we've got 2 of these little suitcasey like storage bins. These are very small storage bins. We also have like these snap open boxes, but this is like all in one. So the gray one is got clear tops. I also got labels if you want to label them. And then we also have a black one, which is anti-static, but the tops aren't clear. So there's kind of 2 options here for which one you want. Anti-static, of course, is better for storing chips. but you'll definitely have to label each one because you can't see through it. So let's show on the overhead. So one thing is these are smaller than you probably think.
Well.
So they're this. Well, I mean, I felt like they were larger. Hold on.
It's like a slice of a lunchbox.
Yeah, it's like a lunchbox,
Yeah.
but slimmer.
It's
I mean,
like-
they're not that small, but
Yeah.
they're definitely compact. And what I do like is that both sides have these little storage bins, and so you can see through it, and you can also label them. But it's good for a small. Hold on, I'll zoom in here.
You want to zoom?
No. Nope.
I'm zooming in. Look out! I'm in the box.
That's
Okay, sorry, I'm zooming out. Okay.
okay. So inside here we've got resistors or something. Again, this is not the anti-static box, so you don't want to. I mean, you can store chips in it if you don't care, or you're not worried about it. But then you can, it's nice and flat, so you can see all the components. Pick them up, store them, and I do like that they have nice, big finger-friendly latchy thingies, and then you can hear it latch open and close.
Yeah.
Connectors, you can store some connectors, but it's not big, so you can't put in.
Make your own electronic advent calendar, as
Yeah.
folks mentioned.
Well, this is like for like many months. I don't remember how many. It's like 150 boxes. I don't remember the number, but it's a large number of containers. So again, this is the clear version, and then it does the latch closed, and then this is the anti-static version. So, hold on. As you expect, you can't see through it because it's anti-static plastic. But I think one of these. Hold on. Let's see, she said it was in the middle. There it is.
It's a little game.
Okay. You can store chips.
Yeah.
Sorry, this way. Oh wait, this got flipped.
Yeah, I think you flipped it. Or I flipped it.
Yeah, so
flipped
good for storing chips, and then of course you'll want to label it. But Scott recommended these. They're very cute and adorable, and they're great if you don't have a lot of space in your workshop, but you want to have a little kit of components, and you don't want to like store all those little bags with labels on them. You just take the parts out and you put them here, and then this is, between these two, like this is kind of all you need to basically have a full electronic component lab.
All right, next up.
Okay, from Chromatech, so they contacted us, and they make a thing that people have been asking for. So these are momentary and toggle buttons that have a neopixel in the middle. So if you want to light up the ring, you can see there's like 3 pins in the middle, and that's like the normal, like the common, normally open, normally close switch. And then the 4 pins on the outside are for like the neopixels as part of the ring. So you treat it like a neopixel, you send neopixel data to it, and it glows nice and smoothly. You don't have to worry about PWMing each RGB pin. So it's very easy to use, and it comes with a cable harness. So you see here, like, there's like this long tail coming out of it. So that tail, you can detach it, but I don't recommend it. Instead, keep it attached, and you can use that you can detach it, but like instead of soldering to those lugs, you can just solder to the ends of these wires, and you don't have to end up like soldering to your buttons. So it also makes it easier to do installation. So it's kind of a very fancy NeoPixel LED momentary button or latching button. And then another nice thing is the NeoPixel signal. There's the output too, so you can chain them if you'd like.
Okay. Next up, the CircuitPython 7 poster. We're going to hold this up. This is actually another example of like weird supply chain stuff. So you think posters would be easy to get? We normally have these right before the launch, but
Everything's taking longer.
Everything takes longer, slower,
we have it
and
now.
half the amount you expect to get. But this is a really neat poster. If you order one, you might get a surprise, and there might be a previous version poster in there too. Sometimes we do that if we have any left over. These are limited edition, as in like we only make a few.
We only make one
for our
run.
team.
Yes.
And then like if anyone else gets them, great. But the contributors and the community and a lot of the folks that's where we send these out to first. But they're available now, and this is The Great Merge poster is what
Yes.
I'm naming it.
Linka.
The Great Merge.
The unnamed MicroPython Python becoming best friends. We are actually keeping up.
Yeah. All right. And the star of the show tonight, besides you, Lady Ada, our community, our customers, the Adafruit team is...
This new breakout, the VL53L1X, it's actually a popular sensor, and if you can tell by the part number, I actually designed this a while ago, and I kind of sort of forgot to release it. But I finally got around to it again. So the VL53L1X is a time of flight distance sensor. We've already stocked the VL6180, which is like the first gen, the VL53L0X, which is the second gen, which I think could do up to 2 meters, and then the 53L1X can go up to 4 meters. It's quite a powerful and fast time of flight sensor. You can get 50 hertz resolution. I think the cone is about 20 degrees, so it's not nearly as wide as like sonar. Like sonar can spread out quite wide. You can get bouncing effects. This is fairly precise. Comes on a STEMMA QT connector. It's plug and play. Another nice thing about this sensor is it does have a default address of OX29, but you can change it if you connect up the shutdown pin. Like it does have the ability, so if you have multiple of them, the library that is released actually by ST, thankfully they released an Arduino library, can remap the addresses. It doesn't permanently remap them, so it kind of has to do it every time. But it makes it a lot easier for you to connect multiple of these sensors. So they're great for robotics or like human-computer interfaces, or like anytime you want to measure up to 4 meters of distance very accurately, very precisely.
All right, do you want to show a demo?
I do, but I need to find where the micro USB cable went.
All right, well, while you're doing that,
There's one here, but it's...
so many cables.
yes. I'll get that together.
I can find you a cable if you want.
No.
Okay.
It was right here. Okay. So, hold on. Okay, so of course it's pointing at the floor. So I can point it at the ceiling, which is about 3 meters, probably hitting that lamp up there. About 4 meters away, pointed at me, but it updates at 50 hertz. And
point it at me, and then I'm gonna make my hand get closer. Okay.
okay, get closer, close. I will say it's not good after, if it get too close, it's not good under like
That's
20
pretty good.
millimeters.
Wow, that's neat.
Like 20. I mean, it says it's closer,
Yeah.
but it's not, I don't think it's rated for that distance. The VL6180, I think, is better at low distances, but what this one is good for is very long distances. Again, it can do up to 4 meters, which is cool. It's a great upgrade, basically, if you have a sonar and you want something with a narrower cone of interest, and, you still get that 4 meter distance.
Okay.
12 feet or so.
And that's new products. Okay, so don't forget the code's time of flight, and you can use that for anything that's in stock. Start putting your questions over on Discord, adafruit.it/Discord. If you put your question in before we do it again, sometimes it's hard to scroll and find them. And you can hang out all the time and ask questions in all the different channels. But let's do some top secret while y'all are loading up some questions
Sure.
from the vault. All right, so we're going to show 2 videos, and then we're going to show a preview of the new graphics for Desk of Lady Ada. So the first one is a new product that we're going to have in the store soon, and the next one is the UPDI stuff that you're working on.
Yes.
All right, Lady Ada, what is this?
Hey, I am checking out a new sample I got. This is kind of cool. It's a stand, and I think it would be really useful for hot air work. So when I do hot air rework, usually like I'm kind of holding it and I'm like tweezing, and that's annoying because I have to hold it. But this stand holds it for you, and then you can put your board underneath, and I can do all my tweezing. And I don't have to worry about holding this. And you can go up and down maybe. This looks pretty cool. So I'm kind of liking the sample. I think I'm going to order this, put it in the Adafruit shop. There you go. Nice work stand. Well, I finally put together my first ATtiny UPDI based programmer and tester kit. This is for the new ATtiny 817 breakout. Unlike many AVRs, this new series is programmed with a UART system called UPDI. And I have this running, the programmer itself is running on this Metro M0. So it's like, hey, where's the board? So I'm going to insert the board, put the right orientation like this, plug it down. And you'll see, it does fuse checks, it erases the chip, it programs, and it actually does a full test of the GPIO of the product as well. This is cool because it's so fast, even compared to using something like a USB console cable with PyMCU prog, which takes like 20 to 40 seconds. This is like 2 seconds to program. Only thing to watch out for if you're using UPDI is every time you write a fuse, you have to erase to unlock the chip. And that only took me a couple days to figure out, but now I know.
Okay, and then we'll probably deploy these graphics on Sunday. As you can tell, nature's healing. Like when you're dealing with multiple crises for almost a couple years, you don't have time to do some of the graphic stuff you want to do. So this is the new retro look of Desktop 88. I'm going to show the video intro with the music that JP just did, and we're probably going to change up the music every once in a while. And we're going to try to update graphics all across things that we're doing, but here it is. And that's top secret.
It is retro.
Back in the vault. Okay, we're going to do the questions now. Whee! Okay, here we go. You ready?
Yeah,
Some of these
hit me
I
up.
might
Let's
have.
do speed round.
Yeah, we're going to do speed round because we're going to get there soon. Okay, let's see. First question, I wanted to build a text-to-speech project, but want to transmit the audio over Bluetooth to speakers. What would be the best way to do that?
A Raspberry Pi will do the job really well. It has the text-to-speech code using something like Festival, or there's other things, and then the audio you can pipe it out of Bluetooth automatically with a Raspberry Pi. So that would work really well.
Next up. Question, repost the datasheet for the LC709203F Adafruit fuel gauge. Says that it's for single. So LiPos, I assume, cannot be used with battery packs that are in the store, like the 440 microamp hour or 6600 milliamp hours or 10 amp hours, correct? Or is my interpretation wrong?
You can use it with those packs. You can't use it with anything that has 2 packs in series to have a higher voltage. Basically, it has to be no more than 4.2 volts when charged.
Okay. Let's see. Do you have a favorite brand, or anyone have a favorite brand here, of hot air stations?
The ones in the Adafruit shop are the ones that I've liked the most. We have a low-cost one and a fancy one.
Yeah.
Those are the 2 best ones.
Next up. Question. Adafruit friends, or Adafruit, can you recommend some affordable types of translucent material to diffuse neopixel ring, sticks, matrix, etc.?
Try the LED acrylic that we have in the shop. I think we sell a 1 foot by 1 foot section, and then we have a smaller section too. You'll have to laser cut them, or you can score and cut them, but nothing diffuses LEDs and looks as good as that LED acrylic.
Okay. Will the new time of flight board have have CircuitPython support?
At some point. I'm not sure when I will get around to it, but
Okay.
I think I will be able to port the library over.
What is the resolution of the time of flight sensor? Can it do more than 1 millimeter? I would like better than 1 millimeter at 25 to 50 millimeters. The software delivers 1 millimeter, but does the sensor do better?
No, I don't even think it does 1 millimeter accuracy. For sub-precision, you'll have to pay a lot for something different.
Okay. Let's see. No, that was something. Folks are helping each other out for that. Is it possible to run more than 1 NeoPixel 8 on a processor?
No.
this
It
time?
takes over the processor. We use like all timers.
Okay. Looks like we got that one. People have a bunch of NeoPixels. Okay, I think I got through those. Let me see if there's any. How precise is the distance for the time of flight sensor?
You can check the data sheet. I think it's a couple millimeters precision. It is one or accurate, right? It'll give you a number. The number it gives you is in millimeters, but I don't. I think it's within like 5%, like 2% or something of the distance.
Like just when I was eyeing it and everything, I'm just like, wow, this is really good.
It's better than a sonar for sure,
Yeah.
right? Time of flight, you're going to get really good. It's basically LiDAR accuracy and precision, but if you want the actual true numbers, check the data sheet. I'm not going to quote them and get them wrong.
Okay. For the MagTag, we don't ship that with CircuitPython.
No.
Is there a reason we don't ship it with CircuitPython?
Yeah, because ESP support is constantly updating, so just install the latest version. It's very easy to.
Okay. All right. I think we're just about how precise distance looks like. Okay. Folks had the same question on this one. Thanks for writing the updated Nunchuck library. You're welcome.
Yay.
I think we got them all.
Ooh.
Yes.
Okay, great.
All right. Thank you,
I
everybody.
think
That was a
jump,
that
through
was
them all.
yeah. We got through them. Those are the questions. I mean, like, you know, for folks who watch the show every week, folks are answering and helping each other out throughout the show. So thank you for that. But
Yay.
also, thanks for saving your questions for the end. So let's wrap up the show.
Okay.
Time of flight's to code. Thanks so
Time
much.
out, including the sensor that we put in.
That's right.
Time out.
Special thanks to Takara, who's running stuff behind the scenes in our Adafruit Slack channel. Special thanks to everyone in the chat that was helping each other out tonight, and everyone who showed up in the show and tell. It looks like an epic show and tell. I can't wait to see that. And if you're here watching this, thanks for sticking with us for the last, decade or so, or if you're just new, or if you've been with us for the last couple of years. I've said this, we have an all-company meeting called State of the Fruit that we do every week, and there's ups and downs when you run a company, and especially over the last 18 months, it's been just really hard for all sorts of reasons. But if you are someone who's looking for like little glimmers of hope, like I think a lot of us are, things are getting better. We have 100+ people. We're all vaccinated. New York City, there's so much stuff going on. The Halloween parade is back. We're doing a ton of decorations here. I think October is our month that, we all thought it was going to be over the summer, but
Took an extra September.
yeah.
So September was kind of like a
Yeah.
leak over of the summer.
Yeah.
It was still quite messy.
And I think it's pretty clear how we get out of this, and us as a company decided to do this, and a lot of us here, we know we're working on something bigger than just an online website, or even just making electronics. There's something bigger and more special, and I'm glad that you're all part of it and you've been through it. I feel like I've aged like 50 years, but maybe we can chill out over the holidays or something. I don't know. But anyways, thanks everybody. We'll
Thanks,
see
everybody.
everybody next week. That's our show.
Bye.
This has been an Adafruit production. Here's your moment, Zener.
Later.